This is interview coding lab, and here the basic what the format that we follow is that I'm going to give you 45 minutes and two problems, and you'll attempt those two problems, and you choose your favorite code editor that you like and your favorite programming language and try those problems. And at the end of 45 minutes, I will solve those problems, and I'll be using Python programming language to do that. But I mean, you're not restricted to use Python specifically. You can choose whatever language you want. And we'll discuss after 45 minutes. So the problem I'm going to post on Discord now. Oops, sorry. It's the lab 4, and I'm going to put this in Discord right now in the coding lab channel. There you go. So there are two problems.
Can you post the Discord link in the chat?
I did. Oh, you mean Zoom chat?
Yeah,
Yeah. Okay. There you go.
thanks.
So the problem number 1 is that given two non-negative integers num1 and num2, which are represented as string, return the sum of the num1 and num2. So you can check the input and the output, and if you have any questions, ask me. You can treat this like a mock interview type. That's the problem number 1. And in the problem number 1, you cannot cast these strings to numbers, right? So essentially, suppose you have a string, let's say 1, 2, 3. You can't do this, right? You cannot write 1, 2, 3 to get you the answer 1, 2, 3. And the problem number 2 is that you're given a string, and the string can contain letters and numbers. And the letters can be lowercase, uppercase, doesn't matter. But essentially, you have to return all the permutations of the string where the letter is both uppercase and lowercase, all the combinations. So as an example, consider this one. So the first permutation is when everything is lowercase. Then you have B as the uppercase. Then you have A as an uppercase, and then you have both A and B as uppercase. You can ignore the letters because, of course, there is no upper and lower case in the case of a letter. Oh, sorry, in the case of a number. So those are the two problems. Do you have any questions?
So there isn't any casting in the first problem?
Yeah,
Like,
no casting in the first one, yes.
okay.
The idea is that sometimes numbers are so big that you're not able to store them in the variables. So they might be stored in the form of a string, and they might be so big that they are kept in a file. So you need to systematically add the numbers, each digit to get the answer.
Do we just solve these individually, or do we like discuss them as we're solving them?
You can first attempt yourself.
Okay.
Yeah.
But if I take one digit, can I cast it? Or just one digit?
See, ideally not,
Not?
but if you don't
Okay.
know how to maybe get the value, then you can do that. Okay, that much liberty you can take.
Okay, thanks.
Yeah.
So we can assume that these strings will contain only digits and not characters.
That's a good question. And yes, the answer is true. The string will only contain numbers. There will not be any characters, like non-number characters. All right, so problem number one, right? You're given two non-negative numbers as strings, and you have to return the sum of those numbers. You cannot cast those numbers to integers directly. So basically, if this 1, 2, 3 is there, you cannot just convert it to 1, 2, 3. Secondly, these numbers can be so large that you cannot, there's a possibility that if you convert them to integers, you may run into integer overflow. So essentially, you have to simulate the sum. Right? When you do that, there are certain complications. So suppose one string is 1, 2, 3. Okay, unless the other string is, let's say, 9. Right? We'll have to exactly simulate the whole thing how we do humanly. So we write 1, 2, 3. We write 9 here. We add 9 and 3 is 2. There's a carry that comes here. Now, if this number is not present here, then you can assume that this is 0. So then you write 2 and 1, which is 3, and then you sum everything else. If there was a remaining carry, for example, if let's say this was 1, 2, 3, and let's say 9, 0, 1, then this will be 4, this will be 2, and then 9 and 1 is 10. So this remaining carry comes here. So you have to be careful about these things. And then there are going to be edge cases, which we will see. So I'm going to code this problem, okay? I'm going to use Sony IDE to do this. I'll be using Python language again, and it's not needed. You can use whatever language you want. Add strings.py. All right, so there's a function we're going to call add, and this function is going to take two parameters, num1 and num2, and this is going to return the sum of those answers. And let's say we're going to say, let's say num1 is equal to a string, which is, let's say 1, 2, 3. Num2 equals to 9, 8. Let's just keep simple this. And then again, we're going to do the same thing. We are going to, let's say, define the string as 999, and this is 888. And finally, we will probably put some large input and similarly some large input on this side. And why are we doing this? Yeah, let's just keep different lengths. There are going to be some edge cases where you can do, for example, num1 equals to empty and num2 equals to, let's say, 5. Then how our test cases are going to handle, we'll need to see. So here's what we can do, right? So first of all, let's start simulating this. Suppose your first string is 1, 2, 3. And the second string is, let's say, something like 9, 5, and 6. So clearly this is a string. Let's just keep it shorter. Let's say 5, 9, and 6. So clearly these are two strings. Right? So indexes of these strings are 0, 1, 2. Let me use a different color. So 0, 1, 2, and 0, 1. These are the indexes. So what we need to do is we need to go to the last element of both these strings. And we need to add the numbers that are represented by these characters here. Right? So first we start with the last character. So what I'm going to do is I'm going to set 2 pointers which are going to go back to the last characters in the string. So the index of the last character for the first string is len num1 minus 1. Right? So let's call this, let's say, position 1. Similarly, the position 2 is len of num2 minus 1. And I'm going to initialize a variable called carry, which is going to be 0. because it starts with 0, and then as we move along, this can be whatever value. All right, so now we're going to start from back from here and going in this direction towards the index 0. And we're going to go till both of the numbers, till the larger of the number reaches 0. And we'll take care of the other number. If we don't find anything, then we'll keep adding 0 in that place. So we're going to start from there and going to come here. So I'm just going to write while P1 is greater than equals to 0, or P2 is greater than equals to 0. Okay. So now we need the two numbers. So the number, the digit 1 on this place is, what is the name? Num1 of P1. And the digit 2 is going to be num2 of P2. Now there is a problem here, if you notice, and the problem is this P1 or P2, for example, if one of the digit is longer, then this may run out of index. So we have to be careful about that fact. So what we'll be doing is we'll be saying P1 minus equals to 1 later on, and P2 minus equals to 1. So let's say when we are reducing both P1 and P2 by 1, so we're going 3 and then 2 and then 1. When we reach here, the index is 0. This is okay, but for example, the index at certain point of time, what may happen is we may make this P2 as -1. It will start at 1, 0, and then it will become -1. And we don't have that index here. So what we have to do is we have to check if this condition is true, then only this is the value. So digit 1 is equals to num1 of P1 only if P1 is greater than equals to 0. Else it will be
0.
Right. Now there is a problem still. If you notice, the problem is that this is a string, and I'm saying otherwise this is a 0. I'm going to correct this in a second. So if P2 is greater than equals to 0, else it is going to be 0. Now, how do we compute the value of this num1 P1? How can we do that?
Do the modulus over 48.
I mean, what will that do?
So you'll get, so like the ASCII digit or the number for the character 0 is 48 in ASCII.
Oh, I see. Okay. Yeah. Okay.
Yeah.
So what I'm going to do is, I'm going to say this minus this, right? So in Python,
Oh, that
odd
doesn't
of
work in
odd of
other
3,
some languages.
and let's say odd of 0, right? So they all have their Unicode code points, and you can subtract them in order to get the answer. So basically, once you have this, what I can do is I can apply this logic here. I can say odd of this minus odd of 0. This code is now, these two lines are looking slightly complicated, but I mean, they are pretty simple if you break it down. So what are we saying? So we're saying if this is still greater than 0, then the number is going to be odd of that value minus odd of 0. If this is not the case, then the number will be 0. Why don't we just print these numbers and make sure that we are getting what we want? So suppose digit 1 comma digit 2. Let's just keep that much. And suppose let's reduce this and just call this add num1 comma num2. So let's run this and notice what happens. The first number is 1, 2, 3, which is being printed like this, 1, 2, 3, and this is 0, 2, 3, because the other number is just 2, 3. So we are in a position to add these things now, right? And these are numbers at the moment. So what is the total going to be? It's going to be digit 1 plus digit 2 plus whatever the carry is coming. So initially the carry is 0, so it will not affect anything. But later on, when carry is something, we will add carry to this. Okay, so now let's say we are adding these numbers. Suppose 9 and suppose this is 1, 2, 3, and suppose this is 1, 9, like that. So when we add 9 and 3, we're going to get 12 back. We need to store 2 here and send 1 to the carry, right? So how can we do that? We need to, yes. So we can do the modulo of that. We can say modulo 10, and this needs to go here as the sum. So we can say I'm going to initialize another variable which is going to store my answer, which is a list. Okay, and it's going to be a list of characters. So I'm going to say, okay, result dot append this value, but not just this value, the str of that value, because we need characters again. So we're going to store this in the result. And another thing, the other thing would be the carry.
Oh wait,
right?
don't
So
you want to prepend it?
no, I'm building it from left to right, and then I'll reverse it, because
Oh, okay.
prepending it will be problematic, because if you notice, if I'm building a list and I prepend things, then there's going to be a lot of shuffling, and that is going to be n square, right? So suppose if you have 1, 2 here, and then you have 3, then 3 needs to come here, all of this needs to move out. So that is n square. But what I'm going to do is I'm going to build it the opposite side. I'm going to say like this, and then in the end, just reverse it in linear time, the whole thing.
Okay.
Right? And the carry is going to be basically total by 10, right? And I'm keeping the carry in integer right now. Why? Because it needs to add again, so I don't need to do anything. Although there is one problem in this code. Let's see if it comes up. Okay, and okay, once we are done with that, then p1, p2 minus 1, and then essentially you can just come out of the loop. And in the end, there is one case where that if the carry is still remaining, right, after adding the whole thing, if the, let's say, digits were
You have to put the carry in at the end.
yeah, 999 plus 999, then after adding these two, there will be a carry in the end.
Right.
So we're going to say if carry, then basically result dot append str of carry. Yeah. So once we are done with this, we can reverse this result. We can say reversed of result. Okay, let me do this first inverse, so that, and then I will do that, so the Python complications are away. So let's just say we are printing this and we say return result here. So this will return the inverted result at the moment. You need to say print num1 and num2. Let's see what this returns first. So we run this code and this returns 641. Right? The answer should be 146. So if there is a list like this, suppose this is your list. Suppose the list is like this in Python. And let's say you want to join this, then essentially you can write a string operation that without any delimiter, join this L. So it becomes this. But before that, you can also reverse the list. You can say reverse of L. Or you can write reverse of L, cast it to a list, and then write this join operation. So essentially you can write this join. Sorry, my mistake. So that becomes 146. And all of this is linear time. First you are reversing the list, then you're casting it back into a list, and then you're joining this. Or you can just write code essentially to reverse the whole thing. It's like a one-liner code as well. So here I'm going to do the same thing. I'm going to say return this thing. Let's run this code. Oh, it's my mistake. There is no variable L. There is a variable called result. So we run this. 146 is the answer. Now let's try this on different things. There is this test case of empty as well. Let's see what happens there. We run this and notice we get the answer for everything. So this is a Python solution, but you can, of course, code it in whatever language you want. Once again, I started with the initial pointers to the last location, initialized the carry to 0, and kept an array, which is this Python list, and I'm going to add each character to it. So I compute the first digit as the string element here, the odd value of that minus the odd value of 0. This gives me the number, but only if this is still valid. Any questions here?
Yes, I have. So when I reverse a list, why should I use cast? Why should I cast it to a list? I don't understand.
The reason is this is a Python technicality. So remember, in order to save the space, this reversed of L will not return a list. It will return a reverse iterator object.
Okay.
You can go and iterate this from right to left, doesn't matter.
Okay.
Or you can just cast it into a list and it will become a list.
So that's not a list. Okay. That's why. Okay,
Yeah.
thank you.
Yeah.
Yeah, I'm not that familiar with Python, but why you didn't use append to a string rather than the result array?
Can you repeat your question?
So why you prefer a result array rather than just having
The
an
reason
empty
is
string?
my choice is this because if you do, let's say, str plus something, if there are too many strings being generated, then that's usually considered like wastage of space. If you're doing this, let's say the string length is, let's say, 1,000, then 1,000 strings will be senselessly generated. Whereas if you have an array, then it will only multiply in size when the twice of its size is exhausted. So when the array gets created, suppose you initialize an array and initially it has size 1, then if you keep adding, it becomes size 2. Then if that expires, then it becomes size 4. Then if that expires, it becomes size 8. Then it becomes 16. So you can see that in the end, there are less number of copies as we move along.
Okay,
Whereas if you
and
do
the string is a copy every time.
every single time, yes.
Got
In
it.
Java, you have a string builder. So you can use that string builder to do the same thing.
Himanshu, I had a quick question.
Yes.
So that is about, I did a solution similar to yours. I posted it in Discord.
Okay.
So I used 2 for loop and yours is consisting of a single while loop. But I think at the end, like, I think even mine is O of n. So I was just wondering, like, in terms of optimization, like, would you prefer, like, if you're doing an optimum solution to just use the one loop solution and show them?
It doesn't matter if you, sorry, the number of operations that are happening
Mm-hmm.
is what counts.
Okay.
So whether it's one loop or two loop, it does not matter. But I'm wondering why would you, I'll need to check your solution to see
Okay.
why
Sure.
there were two solutions, but I can comment on it once I look at it.
Yeah, sure. Thank you.
The one important thing to understand is that many people I see the solution, they are building the integer, right? So if there is, what they have is something like this, that you have a number 951, they initialize an integer to 0, and then say, okay, 9 comes, multiply 9, so put 9, and then next one 5 multiplied by 10, sorry, my mistake. They say take this 9, then the next number comes, then multiply this by 10 and add 5. Then whatever comes, multiply this by 10 plus add 1. This is not okay, right? Once again, I'm explaining this. The reason is you will run into buffer, the integer overflow, if the
I
integer is big.
see. I think
So you
mine is
will,
a similar solution where
yeah,
I have converted the string to an integer and then, okay, got it.
yeah. So you'll have to, yeah, simulate the whole thing one by one.
Got it.
There is a
Thank you.
complicated problem than this, which I will give you as assignment, and you can break it down into smaller pieces as well. You have to do multiplication of large numbers. So it was 951 multiplied by 99. So you have to do this. Both are a string. This is a relatively harder problem compared to sum. But you can take it, you can try it at home. I'm going to go to the second problem now.
I
The
have
second,
a question.
yes,
Like the odd, what is that like? Is it converting to ASCII?
yes. See, the
Okay.
odd is going to represent the Unicode code point for that particular character.
Okay. Yeah.
And the char is opposite. So if you write, let's say 48, this will give you the 0. If you write some random number like this, you will gonna get something else. So for example, this is an icon that you're getting, but yeah, whatever. So
Okay.
let's come back to this problem number 2. So given a string S, we can transform every letter individually to be lowercase or uppercase to create another string. Written a list of all the possible strings we could create, right? Any comments on this? Did anybody try this first?
Yeah, I actually did it. I just used recursion.
That's nice. Yeah. So I think the recursion would be the answer. This like a brute force backtracking type of solution that we'll have to build. So suppose you have a string A1, B1. What you'll have to do is you'll have to construct all the solutions from this. First, you can take the first character and you can say it's small, and you can construct from here. Then the next character is A1. Then the next character is B. Suppose you say, okay, this is also small. And then the next character is 1, A1, B1. Then I'm going to come to this loop in a second. Suppose you said the B is big. So then this can be A1, B. Then this can be A1, B1. Similarly, you can say the A is big. Oh, sorry. You can write not here, but let's say here. You can say the A is big to begin with. And then similarly, you can construct the trees. So everything that's at the bottom will get you the answer. So this is a typical backtracking type of problem. And if you're not familiar with backtracking or you're looking for some background, then there are some videos on my YouTube channel that I'll send you the link later on in the Discord that you can refer to. But let's solve this problem now. And let me create a file. Okay, let's call this permutation. So suppose you have a string S equals to, let's say, A1, B1. And just give me a second. All right. I'm going to create a function and I'm going to call this, let's say, backtrack. Right? This is essentially a backtracking type of algorithm. So here's my here's my approach to do this problem. I'm going to create a function and I'm going to track these things in it. Suppose this is the input, A1, B1. Actually, let's write it little A1, B1. And let's say this is the indexes 0, 1, 2, 3. Then I'm going to begin at the index number 0 and I will take that element out. Okay, so let's say this is the index and this is the character at that index. 0, A comes out. A is not a digit. So then there are two possibilities at this point. Suppose I'm saying that backtrack this guy. So then there are two possibilities here. We can say backtrack A1 B1 or backtrack A1 B1. Then we go to the next character. Okay, so the index goes to 1. And then we say, okay, what is this? This is a number. So nothing we need to do. Then you go to the third character, which is B. Now here again, you have two possibilities. So this called this 2. This will call again backtrack like A1 B1 and B of A1 P1, both the permutation. Similarly, this will call the backtrack of A1 P1 and B of A1 B1. Right, so let's do this. And at this point of time, the index will be 3. Once we reach this position, 3 is 1. And then there's nothing more to do. We have reached the end of the string. Okay, so let's slowly build the solution. So the first argument to my backtrack function is the, let's say, string itself. The second one I'm passing is the index. And the third argument that I'm passing is the current string that I am building right now. Okay, the base case is going to be when this index has reached the length of the string. At that point, we can stop. Just like, for example, when we reach 3 here, we could stop. So I'm just going to write if index equals to len of s. Then let's just print it. Okay, let's say we are going to print the current value that we are building and return from here. There's nothing that needs to be done in this case. If this is not the condition, that is, let's say we start out with the first character. The first character is A. So we will call this backtrack method like this. We will say backtrack S0 and the current is also empty. So we begin with this type of setup. So the first index is going to be 0. So the character here is S of index. Now we need to check that if C is digit, if C is digit, or let's just say if C is not digit, then we have two options to call this recursion again, right? So we can say backtrack S again, then index plus 1. And similarly, let's repeat this. Let's go to the next index and add to the current value the lowercase of C or add to the value uppercase of C. So both the combinations. So build the current value with the lowercase of C. So currently current is empty. So when you start, the first character is A. C is equals to A at the moment. You say if C is not a digit, that is if A is not a digit, that's correct. Then backtrack again on the same string. Now go to the index number 1 and keep the current, which is empty right now, empty plus lowercase of A. So this will essentially, current value here will be A and here it will be A. So that's the current now. Otherwise, if it's a digit, then we don't need to do all of this. We can just backtrack. We can just completely ignore this character and just add C here like this. And once we reach the length of the string, we just print the current for now. So let's just run this code. Let's run this code with our first input and see what happens. Notice that we get the things generated in the correct order. So currently we are printing it, but I think if we want, we can return it as a list. So let's say this is the result, which is an empty string. And I'm going to say, instead of printing this, just result dot append current. And finally, you can just say, let's say print of this guy. Or you can say print of something else. Maybe let's form some test cases. Suppose this test cases are, let's say this, and let's say there is just a number and maybe something else. Let's say A, B1, C2. And then I'm just going to say for T in tests, let's just run every single test case. Sorry, 0, and this is T. So for all of these test cases, run this function one by one. So if we run it, and suppose let's also put T here, T, comma, this guy. So this will give you the answer for every single test case. If we run this now, what did we do? This mistake. This is incorrectly defined. So the problem here is that we are not returning the result. That's the problem. So what we can do is so the problem here is that what I did was I'm not returning anything here. This return is none. So we are manipulating a global variable. So what we need to do is something like this. We say result equals to print result. And before this, say result equals to this. Let's run this. So what we have is we first printing this. Let me clean this up a bit. Sorry about this. Just give me 1 second. I'll fix this in 1 second. Okay. So we are initializing the result to empty, then we backtrack, and then we finally print. So there you go. This A1, B1 returns all the permutations. Then 1 returns this just one permutation. Then you have this, which returns all of these permutations. Any questions on this?
Oh, that's cool. I did it different from you. You built the string like throughout the recursion. I just kept passing the same string over and over again.
That's
or like
okay.
with some variations.
Okay. Okay. Yeah, I mean, there are multiple ways in which you can call this. So this is the standard backtracking type of a problem. If you're familiar with backtracking, then this is actually not that complicated. Any questions?